This is age of science, and in this age, space science and technology have made a very great impact on our lifestyle and living standards. Today, we will talk about space research for sustainable development. I believe that everyone would agree with me that space research products are being used by almost everyone on the earth today in some form or the other. I will give example listing on these 5 topics that I have listed here. Let's talk about the contribution of space research in information. Today, we can, through the space network or the websites, we can learn a great deal of things from almost everywhere. We can learn, even suppose we are living in the tropical region, we can learn about what is happening around us. We can learn about what is happening in polar region, Arctic, Antarctic. We can learn about what is happening on the ocean or beneath the ocean. We can learn physics, chemistry, biology, all, all, all sciences, all mathematics, the humanities, the arts, physical sciences, everything, cooking, every information is available through space methods today. And it is not only that we have information about what is around us or what is uh, within our reach, we can also learn about space, the atmosphere, the upper atmosphere, the magnetosphere, the interplanetary medium, the sun and the solar system, the planets and their satellites, the interplanetary medium. We can learn about stars. We can learn about various kinds of celestial objects that exist, the galaxies, and much, much beyond that. We can learn almost up to the very uh, end of the known universe that we know, the cosmic background and the every most many objects where from even the signals take billions of years to reach us. So that is the amount of information the space technology and space science has provided to us. It is enormous. Let's talk about communication. For communication, I will give you my own example. About 40 years back, after completing my PhD in India in space science, I went to United States to do my postdoctoral work in a university. So I, with my immediate family, was living in US, and my parents, my brothers, sisters, they were living in India. At that time, the only mode of communication was that I write a letter to them and post that letter. That letter will reach them in about 15 days. And even if they respond immediately, it will take again the 15 days to reach back to me. So one cycle of communication, the like message going from me to my family and back to me, was taking something like 1 month at that time. But today, within seconds, I can learn about each other. I can learn about my family members no matter where they are living. I can learn about my friends. I learn about my colleagues. And the time has shortened. And not only the time has shortened, the quanta of information that we can get today through the very high level of communication is also very large. Then it was possible only to write your views and learn the views written by your colleague or by your family member. But today you can send your picture, you can see the picture of your colleague or friend or family member at any distance, at any place in the world, and you can in fact demonstrate things. The person on the other end can see what is in your surrounding, what you are doing, how you are doing, so you can demonstrate live. So that is the amount of communication ability that we have today. Let's now talk about the education. The education in the past used to be that you go to a school, you go to a college or university and attend a class. The teacher will come and you will teach a group of maybe 30, 40, 50, 100, 200 students. But today, neither the teacher need to come to the college or the students also need not be there. There are online courses where a professor or teacher speaks to his computer, and that is put on the internet, and the students or those who want to learn from that course can log into the system and attend the class no matter where they are. And these lectures can be recorded and put on the website. The students can refer to those talks, those lectures even later on, even if they are not able to attend when the actual lecture was being delivered and made live. So the classrooms have become very large. Any number of students can take part. Any time you can take part in the class. And so this has made a very big difference. This kind of education, this kind of methods are very prevalent in the West today. In Asia Pacific region or in the region around us and Africa, these things are now coming up and increasing slowly day by day and will make a very big impact on the education of the global education. Let's talk about the comforts of life that we enjoy because of the space science and technology. They, in the past, suppose you want to make a travel arrangement by train or by flight or by road, you need to go to an agency, you need to go to an office where you go, make payment and book your transport, book your flights, book your train or book your taxi. But today, sitting at home through this internet facility, by clicking few buttons, you can book your air tickets, you can book your train tickets, you can book your taxis, you can book buses, you can make all the arrangements. You can arrange for hotels, for accommodation. You can, so all these logistics can be done very easily sitting from home. Your daily needs like vegetables, fruits, clothes, and essential things that you use at home, you can order them online and they will come to you. So you don't have to make very big effort to do all this in your day-to-day life. So that all has come because of the space science and technology to us. Let's talk about predictions. There has been predictions of weather, the kind of environment or the changes that will take place if you for your location and for many locations all around you and all around the globe. Today, with the very intense, very good amount of observations that has become possible now by space methods, by satellites, that you can learn about the climate, the weather pattern, the winds, and the temperature, and the likely changes in all these can be predicted through the models which scientists has developed. And these predictions, I would not say that they have become 100% accurate, but they are becoming very useful and making our life very, very easy for us. So thus, space science and technology has been of great use to all of us. And in fact, I spoke about these components mainly because this Space Education and Research Foundation, for which I do some work, that is trying to popularize space science through some of these methods. So that's why I gave more importance to this. But there are many other applications of space science and technology that many people enjoy all around the world. One of the very important thing that has happened in terms of communication and observations of the weather and remote sensing, etc., can be assigned to a very famous paper in 1945 by a scientist, Arthur Clarke, who wrote that in Wireless World. And he proposed that if, if this is our Earth, and if we take an orbit, such an orbit that is the satellite there will revolve around the Earth in one day. And in such an orbit would be called an orbit, geostationary orbit, because if since the Earth rotates around itself in one day, and if the satellite also rotates in this orbit in one day, completes one circle around the Earth, that satellite or all the satellites that you see here on this orbit will appear to be stationary from the Earth. And so they are called geostationary satellites. And such orbits are called geostationary orbit. And since Arthur Clarke was the first one to talk about the applicability of that, these are also termed as Arthur Clarke orbit. They are at a height of at an altitude of 36,000 from the Earth. And if you have placed these three geostationary satellites separated by about 120 degrees from each other, and they can look at the Earth, part of the Earth, each one of them can look, and these three satellites alone will cover the entire Earth, can be used for communication throughout, can also be used for remote sensing observation, for climatic observations, for many observations. You can use just these three satellites. Of course, today, and he also predicted that this is likely to happen, likely to be the reality in about 50 years or more. But the progress of science and technology was so fast that it was realized in just a matter of about 25 years. And today there are few hundred satellites in the geostationary orbit, and there are orbits like the other two orbits in which also there are many satellites like medium Earth orbiting satellite and low Earth orbiting satellites. From these satellites, one can make observation of towards the Earth, and you can also look from there outside the Earth. And when you look outside the Earth, you can study planets, you can study stars, you can study sun, you can study the interplanetary medium, interstellar medium, and many all the cosmological studies and the astronomical studies can be made by making observations upward. But here there is one example of the satellite looking downward. A beautiful picture of the globe. Earth is shown here, and you can see the clouds, you can see the ocean water, you can see the land here and here. So such pictures, if you take many times during the day, as a function of time. You can monitor the motion of these clouds and then predict where they are going to rain or where they are heading to, and so that's a very big use of this. Let's talk about uh, on a little different aspect of space science today. Uh, Today we know that the only example of life is on Earth. It is Earth-based life that we know. It should exist elsewhere too, but we are not sure. We have not been able to find it out. Although the life is fairly, you have so many species on the Earth, there is a large diversity that exists of life on the Earth itself. But there is one uh, common aspect or similar characteristics that one finds, that each of these species consists of cells and DNA, etc. So there is a common characteristic in all of them. So today we can determine the necessary conditions uh, where the life can exist, can survive, or can reproduce. And to do that, there are several requirements, but the most important one is the requirement of liquid water. And for liquid water to be retained on the planet, the temperature of that planet should be between 0 degrees centigrade to 100 degrees centigrade. If the temperature is below 0, the water will freeze and it will become solid. And if the temperature is high, much higher than 100 degrees centigrade, the water will evaporate, will become water vapor, will disappear, and will not be conducive for life. So, with these, putting these two conditions, we can calculate that if suppose this is a star here, and a star is the one where from all the energy, all the heat really comes to us. So a star is very hot, like our sun is at a temperature of more than 5000 degree Kelvin, and if you are around that, this the region around that in this vicinity will have very high temperature. So it will be a too hot region. It will be, the temperature will be much higher than 100 degrees centigrade. But then at a distance, certain distance, the temperature will gradually fall and will become close to 100 degrees centigrade. And as it goes further, it will decrease further and will become 0. So this region all around the star, where the temperature is between 0 and 100 degrees centigrade, that scientists call as habitable zone. And this habitable zone uh, is the place, likely place where the life is possible, or life can uh, sustain, or life can remain there. Of course, for all, if suppose there is a planet in the habitable zone, it is not necessary just because of the temperature that there is life. Or if we go there, we will survive. It's not necessary. Because for survival of life, you also need the right kind of atmosphere, the oxygen, the nitrogen, and minor uh, gases, the many of them that exist in our own atmosphere, and keeps it at a comfortable temperature that we all can live, and it allows the vegetation. Those are called greenhouse gases also. So they make a very big difference in our life. So they also are equally necessary. So one need to then further investigate and learn. Today, with the astronomical methods and space technology, there has been several thousand exoplanets have been discovered so far. Of course, and some of them might be in the habitable zone of their star, and some may also have a right kind of atmosphere, but such studies are still to be done but progressing. So the other aspect of space science that I talked today is also that it is sort of finding out where we can have life elsewhere in the space, or where, if suppose we go, we can survive. And in fact, these studies are very important, very useful, very exciting. But all this growth, scientific growth, industrial growth, that has given comfort to us in many ways, is also having a negative effect on us, negative effect on our environment. And our environment is sort of becoming more hot, which we term as global warming. And one of the implication of that is that when the temperature rises on the globe, there will be a sort of ice which is there in large quantity in Antarctic and Arctic regions, and also on mountains, the glaciers. Those will melt, and once they start melting in a larger amount, the sea level of the water level will rise on the globe. And uh, uh, for more than 100 years or so, these measurements have been made. I show here one example that from 1900 to almost present, the continuously the mean sea level is being monitored. The mean sea level is sort of estimated, calculated, and you can see that from 1900 to 1930, the increase in the mean sea level was at a rate of about 0.6 millimeter per year. From 1930 to 1992-93, this has increased to 1.4 millimeter per year. So the rate of increase have enhanced. And from 93 onward to now, there are two sets of observations shown here, one by green color and the other one by orange color. And one of them indicate that there is a rise per year by about 2.6 millimeter per year. Whereas the other one, the orange one, indicates that this rise is even more, it is 3.3 millimeter per year. So, and then scientists have made models, and with these models predict that by about year 2100, 2100 year, the mean sea level will rise anywhere between 20 centimeter to about 1 meter. And this rise in water level will affect many islands, many cities, countries which have oceans around them, and it will also impact very largely, very importantly, in the climatic changes. The weather patterns will change. So it's a very alarming situation. And this alarming situation need to be contained, need to be reversed. And in this, there could be two contributions. One contribution could be natural, and that natural part is not in our control. We can understand that, but we may not be able to so quickly mitigate that. But it is believed that the larger part of this abnormal increase in mean sea level all around the world is contributed by the industrial growth, the man-made contribution. Our lifestyle, our industries have made a big change in that. And in order for so that will lead to the development is going on, but then it will lead to disaster and our development will be of no use. So for a sustainable development, we need to have deeper understanding of our environment, deeper understanding of our surrounding, deeper understanding of the phenomena that are taking place. And to do that, we need more measurements, more ground-based measurements, more satellite measurements. And in order to accomplish that, we also need collaborations, global collaborations all around the world. These three together, the deep understanding, very strong collaborations, and very large increase in measurements will lead to develop, will help scientists to develop concerns that the kind of thing that we should do, the ways that we should have industries, the way we need to have our lifestyle. So those concerns will be developed by the scientists. And these concerns we all need to take care of. And that is our responsibility to take care of all these. And if we do that, then our development will be sustainable, our progress will remain. So for sustainable development, we need to have a deeper understanding, global collaborations, and more measurements, ground-based as well as satellite measurements, and derive from there the methods, the concerns that we should have, and then we take care of that. With this, I close my presentation. So save the environment for life and future. Thank you very much.